All right, so we're going to get started today, and we're moving from the plan, which we've been working on plan so far, into the building's elevations. And I will do demo of drawing the elevation and kind of how you work in AutoCAD with elevations, but I thought I'd take a little bit of time and I will talk specifically about elevations in lecture, but I also want to talk about line weights and go back and kind of refresh. I know I gave you last class, I probably should have done the line weights part of this last class, but I gave you the handout with the sample line weights, but I thought we'd go back and kind of revisit the idea of line weights, and then we'll talk about it in relation to elevations today as well. But essentially what we're talking about when I refer to line weight, it's the relative thickness or darkness of a particular line that you draw. And there's a holdover to when a lot of you took 130 or are taking 130, and when you have to draw by hand, you can naturally kind of create these line weights. And you can do a lot with a line weight in terms of how a drawing reads and what shows what's on top, what's below, those kinds of things. And we want to be able to do those same things in a computer to make your drawings read. And I think certainly for a long time in the world of computers, there was a stigma about, oh, it's a computer drawing, it's not as beautiful as a hand drawing because the line weights aren't there, it doesn't look as good as if you drew it by hand, etc. I think in this day and age, a computer drawing can look as good or better than a hand drawing, but it takes some effort, and it does take some line weights. So we're going to go through those today in depth. There are also a range of line types, I'll talk about those in a little bit, dash, dotted lines, etc., that are also relevant as we go through here. So we have line styles. Solid lines are for visible objects, things that we see that are clear. It could be in plan, it could be in section, could be in elevation, could be 3D. It's just things that are there. Hidden lines or dashed lines are for things that are behind something else, where you can't see it completely. So when you guys were drawing the plans, if you were drawing upper cabinets, for example, they're not seen because the plan is cut right here at 4 feet. They're above that, so we would draw it as a little dashed line. The outline of a roof, the eave, those would all be dashed lines because they're hidden. They're not something that you can see. So we use a lot of solid lines and a lot of dashed lines in architectural drawings. As we go forward into movement or phantom lines, I disagree a little bit because a phantom line, technically, a door swing should be a phantom line. I don't ever draw it as a phantom line. I don't think it looks right as a phantom line. So I disagree with that a little bit, though sometimes when you're doing a section line or whatever, you'll use a phantom line in there. So it does have uses. A leader or annotation line, these are lines with arrows on the ends. So when you're pointing to something, we're not going to do any of that in this class, but typically you'll end up doing that a fair amount as you go forward in drawings. What I mean by a break line, and you've seen this before, is when you're drawing the line and it has that little, it's kind of like a heartbeat line. And typically there's two lines that go together like that. And we do that, that's not quite right, hold on a second. It's hard to do it. It's two break lines, and the idea is that the drawing stops and then continues, and you've cut something out of the center. And so that's an important line when you have too big of a drawing to show. So you want to show that this little piece connects to this little piece, and there's some lines that go in between, but we're cutting those out. So we do those little break lines there. Center lines, if we were doing the center of some objects and we wanted to do that, it's not that common unless you're doing kind of mechanical drafting, where you're trying to show the center of an object. Not that common in architectural drawing. Section lines are really important. I'll show you those in just a second. I've got a bunch of those. And dimension lines showing the dimensions or measurements of an object. Line weights, I think this slide is nice because it's showing us kind of the comparison of line weights. If we were hand drawing, so in this world, construction lines, these are things that as you're laying things out on a piece of paper, they're your background lines, they're giving you general dimensions, etc. Those are going to be done right here in a 6H or a 4H lead. So that's way back to the hand drafting days where you're picking a certain lead type. But in the world of computers, we're at a 0.05. I would say this is 0.00 millimeters in AutoCAD, somewhere in that ballpark, as thin as you can get. So this right here is AutoCAD. This right here is Illustrator. So we've worked in both. So here we go. There's AutoCAD, and that right there is Illustrator. So it gives us both examples here. So as we go up, light lines, these are door swings, that kind of thing. we're looking at about 0.10 in the world of AutoCAD, or 0.3 to 0.4 points in Illustrator. Secondary object, furniture, doors, cabinets, those kinds of things are medium lines, 0.2-ish. Bold lines, outermost boundaries of objects, major things that we're showing, those are going to be in the 0.3 to 0.4. And then cut lines, cut lines are things like the walls that we cut through or a section cut. They're going to be 0.4 and above. Though I think a lot of times the walls dropping down to 0.3 feels a little bit better. It depends on the plan and how intense your plan is. So it's good kind of background information. So one of the things that we're trying to show, and the reason that line weights become so important, is depending on how our drawing is set up, we can show a lot with our line weights. So at the bottom of this page, so everything below that red line here, this is all the plan view. And so if our eyeball was here looking down through this plane at this object right here, this is what we'd see. Does that kind of make sense? So this first one, we're just seeing a little groove in the surface. Okay, so it's thick lines on the edges because it's cut, and a thin line in the center. As we look at the next one, drawing 2 here, this slopes down and away from us. So the boldest line is right there at the topmost edge. Then we have a thinner line right there and right there. And then we have the thinnest line of all here and here. So the further away we go, the thinner the lines become. So things that are closest to us have the thickest lines, and things that are further away have thinner lines. This particular case, we're dropping straight down. So we've got this here as one thickness, then this, because it's got a drop, is a little bit thicker. So we're showing that even a little thicker to show that edge. And then we have the thinner lines right there and right there that are further away. This last one we fold under, and so we're using a different line type. Here's where our hidden line comes into play. In order to tell that it's folding under, we draw that little dashed line right here so we know where that fold is. Likewise, this is our thickest line yet, right along that edge. So we're showing a lot based on these line weights in plan view so that we can interpret what's actually happening in the three-dimensional view. And it's really important to use line weights to your advantage for those kinds of reasons. A few examples of line types. I already was showing you the break line. This top group here is our section lines. The ends of a section line, all of these things here, are really a matter of interpretation. It's based on what you feel looks right or looks good. If you worked in a particular firm, they would have a way of drawing it. Sometimes it's a combination. Sometimes people draw a section line with this little rectangle on one corner, and as it comes across your drawing, on the other side they have the letter. So sometimes it's a mix of the two. But again, it's based on the firm that you work with. They'll have a set of standards. This is how we draw our section lines. Before you're working in a firm, when you're working just for yourself in school, you have to decide what looks right. I would say personally, I err for that top one. That one's a nice clean one. It generally always looks good. It doesn't distract from your drawing. The risk of the letter when you're not doing a perfectly technical drawing is that the letter becomes too bold or you draws too much attention in your drawing. So I think just a little flag on the end really helps. The ones with the arrows also tend to be a little bit distracting. If you're doing just a drawing for presentation purposes, you don't want it to be overly powerful. Dimension lines, we talked about those a little bit. That's showing a dimension. We're not doing any of those in this class, though sometimes you end up doing it. It's kind of its own topic in AutoCAD. We could spend like 2 or 3 weeks talking about just how to do dimensions correctly in AutoCAD. There's a lot to them. Break line we already talked about. A movement or a phantom line is the line with 2 dashes in it. A center line is a line with a single dash in it. The dash line or hidden line is for things that are hidden, not visible in your drawing. Leader line is a straight line with a arrow on the end. Though those can, like this one here is showing a 90-degree bend like that with the text here. You could also have one that comes down like that with a little bit of text. So you've got some flexibility in terms of how they look or what the little elbow looks like. So here's an example of the same drawing 4 times, and depending on which lines are bold, certain pieces stand out or go back. And so as you look at this, even though it's the same drawing, these look like different objects, just based on the line weight itself. So let's talk specifically about elevation views and how do we work with line weights in an elevation view. So we know that the thickest line is the part that you cut through. We talked about that already. So if we look at this elevation, this is a hand-drawn elevation. And so this is where you're really going to see the line weights pretty easily. What's the thickest line? The ground. Absolutely. So, whoops. So our thickest line is right there. So we'll rank that as 1 for being the thickest. As we go down from there, what's the next thickest line on this drawing? It's probably the thing that is closest to us, or sometimes it's the outline of the building itself. And this is a stylistic question. Sometimes people do a dark outline around the building so we see the whole perimeter to make it stand out from the background. Sometimes the next thickest line is going to be what's popping toward us. So I would argue that the next thickest line is either right there, because this little piece is popping out toward us. It's like a little bay window. Or potentially it's that piece, which has a match right over here on this side. So because it's a hand drawing, it's a little sketchy. There's some combinations of line weights when they overlap that make it a little bit harder to see. But I would say that maybe this is 2 and this is a close number 3. And this number 3 goes all the way up there. Is this roof right there? Is right there. And then comes down right there. Oops, sorry, it goes in like that. So we're finding that perimeter of the building. Then when things go further away, like that deck there, that's much further away. This rock set of steps, that's further away. It's less important. This elevation there, that's further away. So it's less thick in its line weights. So let's do another example. Again, hand-drawn, but a little more technical. And we could go through the same ranking process here, where what is the thickest line? I would say the thickest line is probably right there, its match there, and maybe this piece right here, because those are closest to us. So they're automatically the thickest line. As we go backwards in space, things become a little bit thinner. So that would be number 1. Number 2 would probably be this little pop out and this little pop out. So we'll call those 2 and 2. Behind that would be this set. This is 3, right? That's kind of 3 in there. And we work our way back. 4 would be all the way up here. Now, it doesn't mean that you have to use only 3 or 4 line weights. In any drawing like this, there's probably 10 different line weights. And so we have the major lines. These are outlining the shapes. But then we have things like the infill, the siding here, or the little tiny rocks in here. These rocks, let me wipe this clean for a second. If we focus just on that little column, the thickest line in that column is the outside. But then these guys, the rocks themselves, are thinner lines. So it doesn't mean that all the things that are closest to us have the thickest lines. So sometimes the detail, the siding, the rocks, those kinds of pieces, those are thinner, but the outline is the thick piece. So let's look at some computer drawings. And again, line weights here are critical. So we can really easily distinguish what's coming toward us, what's thickest, what's thinnest, based on just the line weight. It helps to have a little bit of shadow here. The shadows are definitely helping, I'll admit that. But if we look at the line weights, right, our thickest line is right here at the deck. Goes right around there. That's our thickest line, because that's popping out toward us. Our next thickest would be this edge of the building, coming around like that. Then we'd go to this, would be number 3. That would be number 4. From an outline standpoint. But we also have a bunch of really thin lines that are showing up. All these siding lines, those are all really thin and delicate. So those would be like the 0.00s. Or maybe they're 0.00 at a 251 gray. So they're fading away just a little bit. And I'll show you how to do that. But that's part of what makes this read as a 3-dimensional object, even though it's a flat drawing. This one's a little bit more technical, but same concept. We can look at it and we can see what pieces are standing out toward us based on which line weights are thicker and which line weights are thinner. The shadows here are really dominant, and they're really helping us to read what's standing out and what's not standing out. Another example here of the elevation. Thickest line is the piece that we cut through. In this case, it's the terrain. Our next thickest line is the outline around the building. Then we get a little bit thinner. I think there could be a little bit more line weights in the windows. I think those could be a little bit thinner. They're a little thick in this particular drawing, and I think that would help it read. The bricks themselves are very nicely rendered in a nice thin line weight. So here, just to show you the transitions, first one up top is just our original, it's actually kind of a half section, half elevation drawing. And then there's two collage versions. With context and light and background and textures, we can do this with our elevation views as well. I like to throw this up there just so you can see that it starts with a quality line drawing with good line weights. And if you have that, then you can get good elevation views that are collaged. A very simple drawing, but at the same time, pretty good with line weights. The things that are closest to us are going to have the thickest line weights. The things that are further away are going to have thinner line weights. This one also shows where the floors are. That's a hidden line. So it's a good use of a hidden line so we understand where those floor breaks are. Another example here of two elevations. Continue on. This one's a little bit more technical, so we're zooming in a little bit. We're seeing a lot more detail about the various materials that are being used. It's actually a bit of a section too. Parts of it are cut through. But as we look at this, you can see that there's a distinct thick line around the objects that are closest to us. There's also a really nice thick line going around the little elevation itself. The section line at the bottom, the part that's cut through the ground, that's the thickest of all. So there's always this scale of line weights going through. Sometimes people add color, but again, it starts with good line weights, then you can add the color. I don't think this drawing has the best line weights in the world. I think if this drawing had better line weights, the color would read even better. So don't just jump to the color. We're going to do color. Well, I'll walk you through that and how you do it. It's really about the line weights first, and then about the color. Another example here, I really like this one because it's so clear on the roof. This is in front, this is further behind. It's just really clear because of those line weights. The line weights are carried through. That is thicker, right there and there, than this or than anything back here. Even this little deck is thicker than that deck, which is thicker than that stair because of how they go back in space. So if you always think about how far something is away from you, that can really help with your line weights. Another example here, this one again has the shadows, which helps things stand out. So some of you visited my site. This is the elevation from the original design review drawings of the building that we were building. This one doesn't have too much detail in it. The line weights, this is really more about color than anything else, though the line weights are there. This was in the front of the packet trying to show, hey, this is what we want to build. There's two windows that are added in this later on that aren't in this one. Then we went to the little bit more technical drawing. Again, this is still design review, so we're moving forward. The first one was about color, general shape of the building, what does it look like. This one has a little bit more detail, a lot of emphasis on line weights. So even the shingle siding pattern, there's a thicker set that's closer to us, a thinner set that's further away. There's a little bit of shadow in there, and the thicker lines going around the building, etc. So whatever's closest to us is getting the thicker line weights. So this is, again, a design drawing. We're trying to sell, this is what we want to build. When we get to the construction drawing, which is the next one, so all these are the same building, same elevation, this is a technical drawing. This is about how do we build this particular building. Notice that the line weights are still kind of there, but they're really underemphasized now. It's not about that anymore. It's about all the details. It's about all the little dashed lines, the hidden lines, the section lines, the detail marks. That's what it's about. That's what I'm trying to read in this drawing. So there's a purpose for each one of these elevations, and my drawings are responding to that purpose. So I'm spending more time with the line weights on this than I am with the line weights on that. Likewise, This drawing for design has the shadows in it, has the siding as a predominant piece. When you move here, the siding's still there, but it's really light, just to show us that there's walls. Does that kind of make sense? For how this is going to change depending on what your purpose is in your final drawing. So if you want to get good at drawing, get good with line weights. That's the most important thing. If people will say, oh, I'm terrible at drawing. I don't like to draw in my sketchbook. Even by hand, if you learn how to draw with line weights, your drawings will come alive. It's just that simple. You don't have to be the best at drawing as long as you start to use your line weights. So today we're going to concentrate on drawing that elevation and actually assigning some line weights to it. All right, so I've now switched over. I've got the drawing that I was working on last class, which is my floor plan. And today it's going to be about drawing the building's elevations. And I think this is a big hurdle for a lot of you because you've worked in plan, you kind of have an idea of what the plan looks like, but you haven't thought about what the roof is going to look like or how you're going to put a roof across this building. Furthermore, there's complexity to a roof. Where does it fall? Where do various pieces of the roof hit one another, etc. Frequently, it's easier to resolve this in 3D. Pull up, SketchUp, pull up Rhino, figure out where the roof goes, and then come back and draw it from there. But for our purposes, we're going to try to figure it out in the elevation view. The simple roof is a flat roof. The more complicated roof is going to have some slope to it. I might end up drawing both. I'm going to start with a sloped roof, though this building I was never intending it to have a sloped roof when I designed it. But I think a lot of you are going to end up doing sloped roofs, so I'm going to show you how to do that. So before we get started, though, I need to think about my layers for this drawing. I'm going to open up my Layer Properties Manager by clicking on the Layer Properties Manager. By the way, I've already switched myself into the drafting and annotation mode. If you forgot how to do that, make sure you turn on your workspace and then switch from the 3D modeling into the drafting and annotation workspace. There I am. I'm going to click on Layer Properties, which will bring up my layer properties right here. I'm going to create a new layer. I'm going to call this A and then South Elevation. I could just do A elevation. I don't have to separate them all, but I'm going to go ahead and do that. I'm going to make that the current layer for right now. There it is. But I'm also going to create one more layer. And so this layer is a special layer. It's a layer that I frequently have in my drawings. And I call this layer a no print. So I'm just going to type no print. And for me personally, and again, this is a completely personal thing, I always make no print layers green. So I choose that bright green color, and then I know it doesn't print. It's just a personal thing. You can make it any color you want. It's just something that I use as a cue to myself. So on this no print layer, I'm going to make sure that I click on the little printer icon, which gives me a red slash next to it. So when I go to print this, it's never going to show up. And so that's important. I'll go ahead and make that one the active layer now because I'm going to create some guides for myself. So it's called no print. You could also call it guides if you want. I think in the handout, do I call it guides? No, I do call it guides in the handout. So it's up to you. Let me go ahead and close the Layer Properties Manager here. And the first thing that I'm going to do as I start to draw this is I want to draw the south elevation right here. So my building's already oriented north-south. There's my compass right here. So the south elevation is going to be this elevation. By the way, some people struggle with which elevation is which. When I say south elevation, it's the south side of the building. It's that elevation. So in a south elevation, I'm actually looking north. That's the weird part. But it's the south wall of the building. If your building is rotated or on axis, you would still just draw your elevation on the closest. So the south elevation, you might have the southwest elevation instead of the south elevation, etc. Most of you probably drew it in normal north, south, east, west, so I'm not overly worried about that. So I'm going to draw the south elevation right down here. And for some of you, it might be easier to turn off the topography. So let's go ahead and turn off that topography layer. There it is. We'll go ahead and turn that one off just so that it doesn't distract you while you're working on it. And I'm going to use my building's plan as a general guide as I lay out this particular building. So I need some guidelines or construction lines that I would pull down from the corners of this building, there, and there, to give myself an idea of what the shape of the building would look like. There are two types of guidelines that are available to you in AutoCAD. One is a construction line. The other is called a ray. The idea of each one is that they're essentially the same thing, except a construction line goes to infinity in both directions and a ray goes in infinity in one direction. So for example here, if I type ray and I start at that corner and I just pull down so that I'm going straight, making sure that I'm going straight down, not at an angle, that's going to give me an infinite line. No matter how far I zoom out, that line just keeps going off into space. So it's a really good kind of guideline for you. And I can continue. I'm going to create one on each of the corners of my building. So I'm going to go ahead and go to ray. I'll repeat the ray command. We'll go there. I'm going to repeat the ray. To repeat, I'm just right-clicking and then choosing repeat ray, like that. And so I've created these kind of guides. The next thing I need is to create some ground down here that I can work from. So this is a good opportunity for a construction line. I can create a construction line by typing X line, or I can use this button right here. Ray, by the way, is right next to it in our little tools. Construction line just means that the line goes in both directions. So same thing here, where it goes off into infinity. So again, those are just construction lines for me to work with. Now as I start to build up this elevation, I'm going to switch from my no print layer to my south elevation layer. So with nothing selected, I've come up to my little drop down here and switched from no print to south elevation. And then I can go ahead and start to draw. I'm going to use my line tool, and I'll draw a line right here across. And if I imagine for a second that my building, what my ceiling heights would be, I might draw another line that went up the side maybe by, let's say 10 feet. I'm going to have a little bit taller ceilings here. We'll come across there and come back down. And this side over here, I'm going to do it at 12 feet. And I'll come back down. And my little bridge section in here, I'll do it shorter. So we'll do that one more at 8 feet. So I'll come up 8 feet and go over like that. If I turn off my no print layer for a second, you can see that I'm essentially massing out boxes for what this building is going to look like. So I'm starting with kind of general massing, and then I'm going to continue to add detail from there. So I have this little piece that was my entry. So likewise, I'd come over to line. We'll start here. We'll go up maybe 8 feet, and I'll go over the top like that. So I'm, again, working out my massing. The thing about a building is that the finished floor of a building, this, is very rarely even with where the ground is outside the building. Generally, there's some space between where that ground is and where the building starts, or the finished floor inside. So this is my finished floor inside. I need to figure out where the bottom of the building would be. A rule of thumb minimum is about 18 inches from where your finished floor would be is where your outside grade would be. Sometimes it's more than that, but I would say it's at a minimum about 18 inches. So I'm going to go ahead and take this line and either offset it by 18 inches or draw another one that is 18 inches down from where this line would be. So let's go ahead and use offset. I'll type offset 18 inches, enter, and there is my new ground. Now some of you might point out, wait a minute, it's on a hill, so it's not really an even 18 inches. We'll come back and I'll show you how to deal with that part of it, but a lot of you aren't at the place in your architectural careers to handle sloping terrain and whatever. So I'm okay if it's flat, but I will show you how to do it when it has an angle to it. I'm going to pull that one all the way over here. So that is now my ground. This is my finished floor. So let's turn off my no print layer here so we can get a little bit better sense of what's going on. This line, if I'm going to keep it, would be a hidden line because I'm not going to actually see it from the outside of the building. That's where my finished floor would be. So I could come over here and switch my line type to hidden to. And again, I'm not going to see it in this view. I'm only going to see it when I switch over into layout paper space, which we'll cover coming up. So as I continue to work through this, I need to know where my windows are. So I've got a series of these tall, skinny windows here. Let me go ahead and turn back on my no print. I'll switch my active layer to no print. And then I'm going to create some more rays. So I'll type ray, and I'll go down from that. I'll repeat the ray, and I'll go down from that. I could do it for all the windows, but since these windows are all the same, I'm just going to do one window and then copy the window instead of drawing it fresh each time. So there it is. I need to have an understanding of what that window looks like. So again, that's my floor. I have cabinets. My cabinets would be 3 feet tall. That's a standard cabinet. So I need to start my window above where those cabinets would be in the kitchen. So we'll do it at maybe 3'6". So I'll go ahead and come up here, 3'6". And that's my first line of the window. I failed to change my layer, so let's change that over onto the south elevation layer, and then let me change my active layer to be south elevation. And I can continue with my drawing here. So I have to decide how tall I want this window to be. Let's do a 5-foot window. We'll come over, and we'll come back down to right there. Now typically windows have some detail in them. So let's take this, and I'm going to join them together. I have them both selected. I'll type join. There you go. Now they're a closed polyline. Then I'll do an offset of maybe, let's do 1 inch, so that I get a little frame around my window. And I might even want some trim around my window. So I could do offset again, and I could do that at maybe 3.5. which would be a 2x4 set of trim, something like that. So I'm just building out my window from there. So I have my first window. I need my second window. So let me take this window, and then we'll copy it for each of these. So I'll type copy, and I'll go from there to there to there to there and to there. And suddenly I have all of my windows. Now it turns out my trim kind of overlaps. So these pieces of trim might not be the best. Maybe I'll do one piece of trim that goes around all of the windows, like that. And then I'll get rid of the individual trim on the windows. So it ends up looking more like that. The alternative would be to make the trim smaller around each window. I could do that. I could take the trim away altogether. It just depends on the look that you're going for on the particular building. Sometimes you want to add a little bit of detail, like you want to add that the trim divides across the top, or that maybe I do the trim like that. Maybe the bottom, you want a little sill under each window. You could add a little sill. And that also means that this needs to come down by another 1.5 inches, like that. So you could do it with a little sill on it. Again, you can keep adding detail if you want. This is all about observation. Go home, look at your windows, see what they look like, look at what the trim looks like, decide what looks right. In this case, I don't know that that's the most attractive set of windows, but it is what it is. Okay? Likewise, over here, this one's kind of a wall of windows with a skinny frame around it. So I need to start adding some detail on this side. So I'll use my ray command again. So let me switch to my no print layer. I'll type ray, and I'll give myself there, there, and there. And so in this case, I have a line. Let me go back to my south elevation. I have a wall that kind of goes up along the side because it's like a little wing wall. And then I have a window that starts, this is kind of like a curtain wall, that starts at the ground level and goes all the way up to the full height of the building. So there it is. Let me offset that we'll do it by 1.5 inches. There you go. And this one probably needs to be divided up into some different panels. So let's do one at a low panel at 2 feet. Again, 1.5 inches. Then we'll take those guys, we'll copy them at maybe 5 feet. Create the next panel, and then we have another panel up top. Maybe these need to be a little higher. Let's move them up by 2 feet. Something like that. So this, again, this is a curtain wall. So we're looking at something like this in here. Once I have that set up, I can go ahead and take my window. There it is. And we can copy it to the other windows here. So I can go to Copy. And there, there, and there. And suddenly I have those windows starting to appear. I still need this little wing wall right there. So let me go back to my no print. We'll type Ray again. And I'll draw that little wing wall. And I'll switch back to my south elevation layer and draw that little wall as well. So if I were to turn off my no print layer, to take a look at what I have, I'd have my windows set up here. I'd have my tall glass windows set up there. But I still need a couple things. One, I need the roof to start to appear. I also need a little bit more detail of what's happening down below. So let me work through the roof next. So a roof is usually a rise over a run. So you'll hear roofs that are 6 and 12 or 4 and 12. And essentially what we're saying is you go up 6 inches for every 12 inches you go over, if it's a 6 and 12. So I need to be able to go through and create what that roof would be. And so this is going to depend on the look. So if we start with, say, a 6 and 12, I need to be able to go from this corner and know what 6 and 12 would be. So for me personally, I don't know what the angle of a 6 and 12 is. I do, but I'm not going to tell you the angles because it's something you have to keep track of. And instead, this is a perfect opportunity to use those coordinates, the relative coordinates. So I could say here, I want to go at, and then I just need a multiple of 6 and a multiple of 12, if that makes sense. So I could go at 12 feet in run, and why is it not doing it? Oh, do I have to turn? I shouldn't have to turn dynamic input on. At 12 feet, 6 feet. There we go. At 12 feet, 6 feet. Now I know that one's way too long, but I went 12 feet over and 6 feet up. Same thing from this corner, only I would be going negative. So it would be at negative 12 feet, 6 feet. And suddenly I have the slope of that roof. So I could trim these off, trim, all, and I could get rid of that. And I'm now starting to look like I have a roof there. So that is a 6 and 12 roof. A 12 and 12 roof is going to be a lot steeper. So I could say at 12 feet, 12 feet. Sorry, it would be negative 12. At negative 12 feet, 12 feet. And I could say, oops, at 12 feet, 12 feet. And I can get a much steeper roof, trim. And so that's going to look different. And depending on what I want my building to look like, I may choose to have that. I may choose to have a lower sloped roof. Furthermore, I could even have a flat roof. So you've got a lot of flexibility in what your building looks like based on these kinds of things. I'm going to go in the middle of these two. I'm going to do an 8 and 12. So let's start here, and I'll say at 12 feet, 8 feet. We'll repeat the line, and we'll say at negative 12 feet, 8 feet. There it is. Then I'll go ahead and trim. So I get rid of that and that. So I now have the ridge of this piece right there. I need the same ridge over here, assuming that the slope was the same. So I'd start there and say at 12 feet, comma 8 feet. Repeat the line at negative 12 feet, comma 8 feet. And then trim like that and like that. So you see I'm kind of working my way through this. So typically, there's also more to the elevation. Sometimes we've got a little eave where this were to stick out, and we want to be able to draw that. There's also usually a thickness to our roof line here. That would be our fascia or our rafters. So I'm going to start by thinking about how far out I want that eave to extend. So if I want the eave to extend out by, say, a foot, I can give myself a guideline here. There's a foot. And then I could type extend. And I want to extend this line out by a foot. See how I did that? So I gave myself an outer border, and then I extended the line out. I'll do it again. So right over here, I want to extend that one out by a foot. So I'll start with a line. I'll track from that point over by 1 foot. I'll come down, and then I'll take this and I'll extend it to that. So I'll type extend. It's also available underneath trim. It's the opposite of trim, is the extend tool. I'll select this and this. I'll press enter, and then I'll extend that line to meet it. And then I can delete that little guideline there. Next thing would be to offset these. So I'll type offset. These are typically a rafter dimension, so we'll do a 2 by 8, which would be 7.25 inches. You could also just do 8 inches, that would be fine. Like that. Then I'll go ahead and do some trimming. Oops. And we'll trim there and there. Now sometimes you want a little bit of extra. Oh, so when it comes to these eaves, I could choose to have them go straight down. I'm going to use a fillet here with a radius of 0 to connect these two. So I could do that. Where this is coming to a sharp point at the rafter tail. Alternatively, I could have this come down and end like that, square. So it's a look decision. If you were going to have a gutter to collect rainwater on your house, you would need to have this as your fascia because you need something flat to nail the gutter to. If you're up in snow country and it's just shedding right off, something like this is perfectly acceptable. So it's a matter of look, it's a matter of decision for you. I'm going to go ahead and keep them square like this. Let me turn on my perpendicular snap. There we go. And that'll let me trim there and there. Okay, so now I've drawn this part of the building. I need to trim off the wall, and I actually don't need this line. This was my interior ceiling. I don't really need to know where that is because it's now part of the building elevation. And so I'll use this and this to trim for there and there. And you can see I'm starting to make that look like a house. So in this case, it's set up a little bit differently. I have kind of like a wing wall that's sticking out toward us. I'm going to transition that over into the roof itself. That's at 6 inches, I believe. Let me double check what it is. Yep, it's at 6 inches. So I'm going to do the same thing on the roof. So I'm going to offset by 6 inches. And this is going to end up necessitating me changing my window height here. So I have those two. I'm going to type fillet so that I can connect this into my little wing wall like that. Same thing for this into that wall. I'm going to get rid of that line across because I don't need that. I'll trim these guys there and there. And these ended up being a little bit too tall. So I'll take these and I'll move them each down. I'm going to select them and then pick this line in the middle, which is the stretch point. And then I'll specify how far I want that stretch point to move straight down. So we'll go down by 3 inches for each one. That puts them underneath that window. Actually, let's do a little bit more. There we go. So I can do this for each of them.
How come you, when you're offsetting the roof, you offset it inside instead of outside?
I could have done it outside. Well, I'm not. Yeah, you can absolutely do that. I'm not actually being perfectly technical about how you would determine where the roof is. It has to do with the wall and the plates and what the bird's mouth looks like. I mean, there's a lot of technical detail to the section that we could go into, but it's just not relevant for you guys at this point. So I'm doing kind of basic. Just go from the corners and come up. Usually you would have to add, and the roof would be taller than where your ceiling height would be. Okay, so that looks a little bit better, like that. So I've got this roof, I've got that roof. This part of the building, I don't really know where that roof is going to be because I haven't drawn a section through that building to find out how tall that roof would be. I need to do that to find the ridge line because it's going the opposite direction. For our purposes here, I'll go ahead and I'll just draw. I'll just draw it as a flat roof. There we go. So let's take this. I'm going to offset this by 1 foot, like that. That'll be the roof for this particular section. Boy, this is turning out to be a really ugly building, but such is life. And I'll trim that part off because it's behind. Likewise, I have this little entry alcove here with some stairs. So on this edge, I've got a little 6-inch wall, so let me offset that by 6 inches. I'm going to have this roof continue down. So let me go ahead and draw a line. At 1 foot over. Then I'm going to take these two and this and extend. So that comes all the way over like that. I'll draw that there. And then I need to trim there and there. Let's delete that one. Perfect. So I'm drawing that as my little entrance there. This one had some stairs coming up to it, so let's pull this all the way down like that. I've got the finished floor height that we would see here, and then I've got some stairs. So I'm going to offset these. I'm going to do them generically at 6 inches. So there's one stair, there's a second stair, etc. This edge of the building would come all the way down. We already have this piece as hidden because it's the floor height. This edge of the building needs to come all the way down like that. This edge of the building likewise needs to come all the way down there. And this edge of the building needs to come all the way down to there. So I've gone through and I've drawn my building's elevation, ugly as it is. Next thing I need to do is start to assign the line weights so that I can see what this is going to look like in 3 dimensions. So the bottom line, the ground, is going to be the thickest line. Furthermore, it really needs to extend out beyond my building a little bit. So we'll extend it out by 3 feet on either side, like that. And then that's going to be the thickest line of them all. So I'm going to select it. Now, when we did the plan, we had separate layers for doors, and we assigned line weight by all the doors are going to be 0.9 millimeters or whatever. When we're doing the line weights on an elevation, typically you end up assigning line weights kind of manually as you go, because you're not going to have separate elevation like elevation ground, elevation window, elevation. You're just going to go through and assign some line weights. So once you have the elevation kind of drawn out like this, I would go through and just assign line weights. So the bottommost line there, the ground, needs to be the thickest line. So I'll select it and then come up to my properties and I'll say, okay, that's going to be a 0.5 line weight. So it's going to be my thickest line. Now as I look at my building, this is closest to me with these little wing walls. So I'm going to take my wing walls, there, those two, and those two, and I'm going to make them the next thickest as I go down. So we'll go to, I could do them at 0.4, but it's probably a little thick, so I'm going to do those at 0.3. Next one would be this, and my roof. Now I've got a little bit of problem because the roof ends here, and then this one's set back further. You can see it right here. It's set back further. So in that scenario, I actually need to break this line. And it's a little bit complicated because I have this line running through. So I can do two things. One, I can use the break tool, or I could offset this little piece by, say, 1 inch, and I could trim those two pieces. Essentially what break does is it allows you to cut a line in half. So I'm going to type break, and I click somewhere on the line, and then I click where I want it to end. So I'll repeat the break, there and there. And then I need to extend these two lines back to this point. So I'll select them, I'll choose extend, and I'll extend those back like that. So now these lines are separate from this, which is how I need it to be. So we'll select those, we'll select this. So these would be my next line weight. So I did the last ones at 0.3. I'll do these at, say, 0.25. As I look at it, my stairs and my building in the middle here are going to be the next ones. So there, I'll select that roof. I'll select this, and we'll go down from there. So we'll go to maybe 0.20 for those lines. The stairs themselves here will go a little bit thinner. So we'll go at maybe 0.15. The outermost boundary of the window I might do at 0.15. But the inner details of the window, I'm going to go down even further. We'll do it at like 0.9. Same thing with these guys. We'll select those windows there. And we'll do those at maybe 0.9, like that. So I've worked my way down in my scale. Now the other thing that sometimes people want to do is they want to add like texture or siding to the building. We can do that using our hatch tool. You guys did hatch before, so it's the same strategy. We'll use the hatch tool here. You can pick what type of siding you want. So if you wanted a brick building, you could pick that. If you wanted like shingle siding, you can use the shake like that to do it. Or you can pick any one of the other ones. Sometimes the simplest is just to do your normal lines and then adjust the scale. Let's do 20. Again, we're looking for the correct looking scale. So maybe about like that. And then I would decide, did I want it vertical or horizontal? So I could say if I wanted it horizontal, or if I wanted it vertical, I could turn it so that it was going vertical. Again, it's a matter of preference. Now in this case, the siding would come all the way down, or it should come all the way down toward the ground. If we're being technical about it, the siding would actually come down to 6 inches from the ground, and you'd see a little bit of concrete below. So we'll go ahead and do that. As a guide, this edge here would be very thin. So I'll change the line weight on that to be 0.00. I'll come back to my hatch, and we'll fill in there, that, and that part of the building there as well. Oops. Somehow I ended up doing more. Maybe I didn't have it completely contained. So let's go ahead and do this, this, this. All right, I'll stop there for right now. But you guys get the idea. Now on this, for the hatches, I want to take a look at the properties of the hatches. So I'm going to go back to my hone ribbon. I'm going to come over here to my line weights. I'll set those at 0.00 because I need them to be really thin. But then I'm also going to change the color to a gray. And so I'll come over here and I'll pick maybe a 251 gray. And that'll make those fade away on the elevation quite a bit. So I'm working my way through the elevation. So I've finished this elevation. I don't quite know how I deleted that line right there. But it's time to start working on the next elevation over here. So I have this elevation done. I've assigned the line weights. I want to move on to the next elevation. So when I start to move on to the next elevation, there's a relationship, obviously, with the plan and the elevation, but also with this elevation that I've already drawn. So this elevation happens to be a really simple one for me to draw. There's not even a window on it. So I'll do that one next. So when I start to create this, at this point I'm going to switch back into my no print layer. And I'm going to go ahead and draw what's called a bounding box around my whole building. And I'll do that using the rectangle tool. And I need to find the outermost corner. So this corner right here is the outermost corner. This is the outermost on this side. That's the outermost on that side. So if I set my 2 points, let me show you how I did that one more time. So I'm starting here. Then I'm going to go to this point and set a point. I'm going to go to that point and set a point. And as I move up there and there, it will snap. This line is a rectangle that completely contains my whole building. Do you guys see how I did that? This is really important. Yeah. I don't hover over it. Yeah.
And we're disregarding like stairs, decks.
You could disregard stairs and decks and that sort of thing. For the building, yes. I think it's not worth you. Technically speaking, you could include it. You'll see where I'm going with this. It has to do with how you transfer measurements around corners. So it's easiest if it's like that. If you wanted to keep going, I guess I could include the whole set of stairs. Let me go ahead and do it that way from a technical standpoint. Let me go to there. So I just hover over that point, and where those two meet, like that. It probably makes sense to include it because I've got this little pop out, because it's not just the deck, it's actually part of the building or the roof line. Okay, so I have that. So the next thing I need is I want a ray that starts at this corner that goes at 45 degrees. So I'll go ahead and choose my ray tool right there. I'll start right there. Now, previously we've always just clicked. You know, it's either horizontal or vertical, etc. At this point, if I look at my dynamic input, I have a distance, but I also have a degree. You guys see how it says angle 312? If I press the tab key, I'll switch to specifying the angle, not the distance. So at this point, I want it to go negative 45. Then I'll press the tab key again, and it'll lock me in at a 45 degree down angle. I could do the math and do whatever, 360 minus 315. I could type in 315. To me, it's easier to do negative 45. So at that point, all I'm going to do is click, and I've created a line that is exactly at 45 degrees. You could double check yourself by creating it again. Sometimes that last click is a little awkward. So I'll go ahead and type tab, and I'll type negative 45, and then tab again. Yep, it's right on, and then a single click. So I ended up with 2 of them. You don't want to end up with one that's off, like that, because it won't pass your measurements through as easily. Okay, so I have that line from the 45. Now, when I start to create my guides over here, I'm going to go ahead and type ray. And remember, it's the outermost corners of the building that I'm starting with. So there and right there. That's where the edges of my building are. But I can also pull things around like where the ground is. So I can type ray at the ground. And where it intersects with this 45 degrees, I can go up. And that's now my ground for this building. So I can switch over into my elevation layer. And I could create a new, this could be the east elevation. And I can draw where the ground would be. Next thing I can do is I can say, okay, well, I want to know where that point is. Let me type ray. Sorry, I have to switch my layers into my no print. I'll type ray, and I'll go to there, and I'll go up from there, and I now know where that corner would be. So I can switch my layers over into the south elevation, and I could go ahead and I could draw that line there as well. So I'm using this elevation to help me with this elevation. Does that kind of make sense how I'm pulling it around? If you took 130, you had to do these kinds of things. So hopefully it's still in the back of your mind somewhere. So for me personally, it doesn't make any difference whether I draw on the right side. I could draw the elevation upside down. It wouldn't make any difference because I was trained in drafting like this. For you guys, you're not as experienced in that kind of drafting. So AutoCAD actually lets you rotate the view. You're not rotating the objects, but you're rotating the view. So if I look over here in the north, south, east, west compass, there's little arrows up at the top here. I can actually rotate my view around, choosing which direction I'm looking at. You guys see how that works? And that makes it a lot easier when you're starting to draw this elevation. Somehow everybody always sees it standing up, and that makes it a little easier. So at this point, all I have to do is continue with what I was doing. So we'll go ahead and switch back to my, my no print layer. I'll type ray, and we'll go to there. I'll repeat my ray like that. I'll switch over into my south elevation layer, and I'll draw the top like that. Then I would need to draw this vertical line. So there, I'll repeat my line, there, there, and there. I need to know where that floor would be so I can do the hidden line for the floor. I already have that construction line, so I just need another ray that goes over. And I can draw that line across there. And now I have where that finished floor would be. Now, sometimes you want to be able to, you know you already have a line that's at the correct line weight and line type, and you want to just match it. You can use a command called match prop. It's also this big button right here, match properties. And when you do that, it's going to say select source object. So I could say that line's my source object, and then apply that line to that object. So I can do the same thing, match properties for my thickest line, right there. And I could say, okay, I want it to be here, there, 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 and there. Likewise, I could go to match properties. I want my ground line. Oops, sorry, wrong direction. I want my ground line there to match that line there. So I'm using that other elevation that I already did to kind of reference my drawing. So I could extend this out by 3 feet. Kind of like I did on the other. Oops, sorry about that. And we could pull that out by 3 feet. On this particular side, I'm not doing any eave, so I'm not showing any eave. So it's kind of a really simple elevation. There's not even any windows on this. I probably should put some windows on this wall. And that may be something that you discover as you're drawing that, you know what, I really do need to have a window on this particular wall. In which case, you go back to the plan, add the window, and then add the window in the elevation view. So in this case, if I was going to go ahead and add the siding on it, I need my line that was 6 inches up and over. That line was at 0.00. And then I could go into my hatch, and we'll fill in there, there, and that really is roof. But I need to change my degree like that, so that it's going vertically. Same thing applies. I can match the properties to this. So let me click on the Match Properties button. I'll select the source, which was this one, and apply it to that one. The only problem there is it matched the same direction, so I have to go back and take this one and change that direction to -45 to get the siding going the direction I want it. Okay? So I'm not going to keep making you watch me go through the elevation views. I'm also not going to show you how to deal with the topography yet. I will come back next class. I will show those of you that want to do the topography how to do that. I would rather have you spend the next couple hours trying to draw as many of the elevations as you can. This is part of your assignment for this class. So you need all 4 elevation views. So take your time now to put those 4 elevation views together. That's important.